Hello, so we're now working on indices and problem solving. So I'll take questions, I'll keep on solving as much as I can. If I'm tired, I stop the video, start afresh to another new video, and we'll just keep on solving questions. And I will recommend, I'll ask you please in the comment section, drop down as much questions as you can drop down, but not all of them, because I won't have to solve everything for you. That's why you have to do your assignments. So but please just drop down questions that you've tried solving and it's proving difficult. Then we'll do it together. We'll see how far. If we can't solve it, then we'll do it as a project. So that's the good part of learning when it's synergized together. Okay, so let's take a question. Now, I have some written down in my book here, so I'll just keep on writing them as I'm saying it. So let's write this question out. We have this simple one: 27 raised to the power of 1 over 3, and then everything raised to the power of 2. Sorry, it's slanty, but let's continue. So remember I told you this is raised to the power 1 over 3. What comes to your mind? Fractional index law. So fractional law tells us that anything raised power, that the denominator becomes the what? It becomes the what? The root. So that if you got that they're correct, so that will be then the third root of 27, and then everything is raised to the power of what? 2. What's the third root of 27? Is what? 3. Because I know that 3 times 3 times 3 will give us 27. Raised to the power of 2. What's 3 raised to the power of 2? Is like saying 3 times 3, and that's what? 9. Easy question, right? Very simple. Let's take another one. Now I have this question also in my book. It's saying 36 raised to the power of 1 over 2 multiplying 64 raised to the power of minus 1 over 2, and then multiplying 5 raised to the power of 0. Now let's solve this one quick. So let's call this one question 2. This is question 2, and this is question 1. So still on question 2. Now on question 2, we have 36 to the power 1 over 2. It's like saying we take the roots of it, right? Because this is fractional law. So the root becomes the square root of 36. Now I might not need to be putting this 2 every time, because you can still use the root sign without using these 2, so I don't need to always put it 2 every time. But whenever I put it 2, it's still the same thing. It doesn't really matter. The only time it matters is when you're using other numbers that's not 2, like 3, 4, 5. You must put it. But when it comes to 2, you don't need to put it. This is still meaning square roots. So square root of 36 times. Now here's negative law. This is the first apply the negative law. Negative law becomes 1 over, we now have 64 raised to the power of 1 over 2. Let's take it step by step. Times 5 raised to the power of 0. Now what's square root of 36? It is 6, because 6 times 6 will give us 36. So square root of 36 is 6 times 1 over 64 raised to the power 1 over 2 is like saying the square roots. Now I told you I don't need to always put that 2, so let me take it out. So it's like saying the square root of what? 64 times 5 raised to the power of 0. Anything raised to the power of 0 is what? 1. Remember. So here is then the 6 times. What's the square root of 64? It is 8. So it's 1 over 8 times 1. And this is what we do. So we now have to multiply. Now I know that 2 can divide 6, which is 3. And 2 can also divide 8, which is what? 4. Right? So we're now having 3 times 1, which is 3, divided by 4 is, our final answer is what? 3 over 4. And that's the answer. Okay, so let's take on that question again. I have one more question. I have more questions, so I'll just keep on solving until I think maybe I've spent enough time. So let's take another question. I have this one here in my book. 9 raised to the power of minus 1 over 2 over 27 raised to the power of what? 2 over 3. Now this is sweet. Okay, so remember I can solve this by breaking them down easily, but let's see how let's solve them. So solving this particular one, remember 9 raised to the power 1 over minus, this minus is telling me negative index law, right? Yes. So I can, let's bring this out separately so you see what's happening here. 9 raised to the power of minus 1 over 2, you can say it is dividing, or you can just, you can say it's dividing 27 raised to the power what? 2 over 3. I want to just use this so that you can see what's happening here. Now notice something before I start bringing them out anyhow. Let me just show you something that's happening here. If you notice that 9 and 27, they have a common base. Notice this. Now in indices, you always need to always have a sharp eye, a keen eye, to notice when a number or numbers appearing have common bases. Notice that 9 and 27 have common bases. What is the common base here? Look at this, 9 and 27. What's common base? It's 3. Because 3 raised power 2 will give you 9, and 3 raised power 3 will give you what? 27. Are you seeing that? Therefore, I will convert these values 9 to their common base so that I can easily simplify it using indices. Is that okay? So what happens here? This 9 becomes 3 raised to the power of 2. But remember, because it's already carrying a power, I put it in brackets, and then raised to the power of minus 1 over 2. Dividing, here is what? 3 raised to the power 3. Now, because this is already having a raised power already, so I put it in brackets, and it's having 2 raised to the power 3. Right? Now, I can open this by using my product law. Product law tells us that whenever I open it, it multiplies everything outside the brackets with that which is inside the brackets. So 2 multiply minus 1 over 2. Now, when 2 multiplies minus 1 over 2, notice something here, that 2 will cancel out 2 here. Is that true? And when 3 multiplies this, 3 will cancel out 3 here. Is that okay? So what do we have? We have 3 raised to the power of minus 1, because 2 cancel out 2 is now remaining just only minus 1, so it's 3 raised to the power of minus 1. Dividing, here's 3 raised to the power of what? 2. Okay, so now we are left with the same base having a division symbol holding it. So remember what happens when we're having division sign and we're having the same base? We go to what? Our subtraction law. And that gives us what? That tells us that we have 3, pick one base, and that'll be minus 1. Our subtraction law, because this division becomes minus 2. Is that okay? And that is what? Minus 1 minus 2 will give us what? Minus 3. So that's 3 raised to the power of what? Minus 3. And we can say we are done here, or we can just put it as, because of this minus sign, we can put it as 1 over 3 raised to the power of 3. Or you can still open this 3 raised to the power of 3 to be 1 over 27. And we're done. That's how easy it is. Okay, so let's take more questions again. Let's move my screen this way. Let me take one more question before I close the video and maybe start another new one, solving more tougher questions than this. Okay, let's take one more question. Now I have this one here. Draw my line. Oh, what's happening? So let me fold that screen. So I draw my line here. Now I have this question. 125 raised to the power of minus 1 over 3 times 49 raised to the power of minus 1 over 2, and then times 10 raised to the power of 0. Now this should be very easy, I believe so. So solving this one, what happens here? Here is 125. Now I can easily tell you what's happening here. Look at something here. I can write this my 125 in bringing it out in the indices form of 5 raised to the power 3, or I can just apply this law straight away. Whichever one, it will still work well. So I will solve it 2 methods: writing it first either in their indices and then solving, or I just apply the law holding this. So let me write first in their indices. Now 125 can be written in the index of 5, that in the base of 5, sorry. So the base of 5 will be what? 5 raised to the power of 3 will give us 125. I know that because 5 times 5 is 25. 25 times 5 will give me 125. So I have 5 to the power of 3, all in brackets, minus 1 over 3 times. Now 49 also can be written in its base of what? 7. 7 raised to the power of 2, all in brackets, minus 1 over 2 times 10 raised to the power of 0 is 1, and 3 raised to the power of 0 is 1. So what happens here? I can see that 3 can cancel out 3 here, 2 can cancel out 2 here, and therefore what do I have? I have 5 raised to the power of minus 1 when it multiplies, and then multiplying 7 raised to the power of what? Minus 1 and times 1. So what happens next? I can then multiply everything through. Now multiplying everything through, remember this is having minus 1, so I can just now they are not the same basis, so I cannot just use that addition law. I have to multiply it normally. So but multiply it normally, let us apply the negative index law here. So 5 raised to the power of minus 1 is like saying 1 over 5 according to the negative index law, times here is what? 1 over 7, and then this is then multiplying 1 over 1 still. So when we multiply this, 5 times 7 is what? 35. So it's like saying 1 over 35, and that's the final answer. Or you can put it in the negative index form as 35 raised to the power of minus 1, which is still correct, because this can be written as 35 raised to the power of minus 1, which is still reversing it back to this case. Now that's one way of solving it. Another way of solving it, as I told you, is that, let me move this my screen. Sorry, I think I moved it too much. Is that I can, let me bring out this question again. This question, I have to bring it out again. So I have this, I have the question here. 125 raised to the power of minus 1 over 3 times 49 raised to the power of minus 1 over 2 times 10 raised to the power of 0. Now I can solve this by applying the law from here straight away. So my negative index law tells me I will do what? 1 over 125. Then I have this raised to the power of, raised to the power of 1 over 3 times, here is what? 1 over 49 raised to the power of what? 1 over 2, and then times 10 raised to the power of 0 is 1. Okay, so what's the next thing? Let me switch to black. Then I have this 1 over 3 is like saying this cube roots, right? So there's cube roots of 125 times 1 over, here is the square root of 49, so I can just write square root of 49. I don't always put the 2 times 1. And then what's the next part? I can then check it out. So what happens? 1 over the cube root of 125 is what? Is 5 times the square root of 49 is 7 times 1, and we're back to what we just did here. So you can continue from there, and we know it's going to end with what? So let me move this my screen, because I don't want my face to always to block it. I know my face is blocking this, so I can move this, and then it finally ends with what? 1 over 35, or 35 raised to the power of minus 1. So that's it for here. So next one we'll be taking more serious questions and see how we'll attempt it using indices. Thank you.